Hey, what's going on, folks? It's Mike here, and welcome to our next lesson in our Modern OpenGL series. In this lesson, we're going to continue where we left off from and go ahead and start building our actual camera in the code. So with that said, let's go ahead and just take a look at this brief recap here from the previous lesson. If you haven't watched, I think it'll be useful, but the basic idea is we're going to take advantage of this function here, lookAt here in the GLM library to build our camera. Now we're going to need a little bit of abstraction. I think it's time to start breaking our source file into just a few other pieces of important components, and then we'll go ahead and be able to use our camera in our current scene here. Alrighty, so with that said, let's go ahead and dive into our code a little bit here. And what we go ahead and do is just make sure that we have a clean build here of our program. And I'll bring in this window here that we've got. And again, we're sort of moving with the arrow keys, but again, we're transforming the actual vertices in this object. So we're sort of moving it around in the world space here. And then left and right is rotating our actual object here. It's performing a rotation around where we've sort of pushed it. So this gives it this sort of orbit around our scene here. But we will actually want to create a camera here. So how I'm going to start this off here is let's just go ahead and create a camera class here. And let's go ahead and do this from the scratch here. And let's see, let's go ahead and create this header file for our camera. And there we go, end if here. Okay. So again, if you recall from our previous video, from this lookAt matrix, we know we're going to need at the very least an eye, a center, and up. And that's going to make up this view direction here in our actual scene here, or rather the actual matrix, I should say, is made up of the eye, view direction, and up vector. And GLM will produce us a 4x4 matrix that we could just multiply through. Okay, so that's what we're going to have here. So at the very least here, if we create a class here, and I'll create it as a class here, although I think I'm probably going to end up making everything public anyways, we're going to need to have a few vectors here. So let's go ahead and include our GLM library, which is in the GLM HPP. And then we're going to need a few of our GLM vec3s here for the eye. And let's go ahead and replicate that a few times here. And let's just call member I member. I like view direction a little bit better. It's a little bit clearer than center. And then up vector. Okay, so at the minimum, that's what we need for our camera here. Now, I think for this particular lesson, we'll probably just mess around with the eye here. So let's just go ahead and write a few functions here. And what I'm going to need here is the important function that returns a 4x4 matrix, okay? Because that's what we're going to multiply through. Again, looking in this diagram here, if I go ahead and grab this here, to go from our world space to our camera space and so on. Okay, so that's going to be the idea there. So I'll need some sort of matrix here, and let's just call this, well, let's see here, what do I want to do this? And I don't necessarily need to expose this, so this is going to be private itself as well. I'll just call it the view matrix. And then I'll need some function here that returns, let's indent this properly here, our view matrix. So it's going to return a mat4 here. And let's just call it get view matrix. And it's not going to modify it, so it could be const correct, although, you know, as you're just learning these things, good habit to get into, but let's make sure that we have it here. Then we're going to call that GLM lookAt function. And let's make sure it is all lowercase here, lowercase and uppercase. And that's going to be made up of the eye, the view direction, and the up vector here. Okay, let's make this a little bit bigger here. Up vector. All right. Okay, so this at the minimum is what we're going to actually need to get our camera moving around. Now, again, I'm going to probably opt for, let's make all of these private here. Let's go ahead and give ourselves some comment here. The ultimate view matrix we will produce and return. Okay. So I guess there's a few thoughts here just on the design as I'm doing this. Maybe we don't need to store this. I actually need to think about this if we'd want to store or cache this. It's probably enough to just return and calculate this. So let's get rid of this here. And then let's put this as our comment here for this getter function, which is just going to construct it from these three members here. And then for now, I think in this video, what I want to do here, just to make sure that we get things working, is let's just create some functions like moving forward and backward, which just update the eye position, let's say. And then we'll kind of iteratively build on these as we understand a little bit more of the math here. So I'm just going to say move forward for now. And actually, let me make sure I do these properly here. Move forward. We're going to implement these in the C++ file. Move backward. And let's go ahead and say move left. And move right here. Okay. So let's go ahead and start with that much and see if we can set up the framework for how this works here. Okay, so this is going to be our camera file. Let's go ahead and split this and create a new source file here, camera CPP, include lowercase our camera HPP. Okay, and let's see here. How do I usually do this? Well, we need these few functions here. So we just copy and paste them. And we've got to make sure that we have the class scope here. These are all part of the camera class scope here. Something like this. Okay. And let's see if we just select our whole file here and just do equals. It'll indent it nicely. Here we go. And let's get our parentheses or our brackets in order so that we can actually update these here. Okay, so that's looking pretty good to me so far. Now let's update how we're going to actually compile this, see if we're good to go. Hit enter. Let's see if I made any mistakes here. Looks like a few silly ones here. Okay, GLM here looks to be missing, so we got to figure out where that is. So again, let's practice reading our documentation here. GLM lookAt, and I get a little clue here, but let's scroll to the top here. And this is part of the matrix transform here. So we can see that this is the header file that we need to include here. Okay, so you can just go ahead and copy and paste these, but let me actually be sure here. Let me go to lookAt here. Let's see here. lookAt, see if there's anything else that needs to be brought in. Yeah, I think it's just that matrix transform will do the trick. Okay, now we have the actual source files, so let's just give this a try here. My GLM. All right. Oh, and I've gotten a little ahead of myself in my header file here. Some of you are probably, yelling at me for putting the code in there. Talking about what it does now. Let's actually make sure that's just here. Oops. Okay, I gotta just make sure I'm in the right mode here. Okay, let's go ahead and include this. Let's see if that makes us a little bit happier here. And in fact, it does. Okay. So we've got things set up here to have a camera view matrix that we can retrieve, and it'll move us somewhere here. Now I am actually going to want to set up a constructor as well. So let's go ahead and set up a camera constructor just to set up some good defaults for us. Let's go ahead and call this the default constructor for our camera and set that up again appropriately as well. Okay, and we have the eye, which should be some GLM vec3. Let's position us at the orbit, or excuse me, the origin. And let's see here. Importantly, then we have our up vector, which again, I'm going to assume this. I mean, we have to sort of pick, I suppose, that up in our world is just going to be on the y-axis, that we always start off on a plane here. That may or may not be true, but again, this will be useful for us. So assume we start on a perfect plane here. Okay. And then we're going to need for our view direction. And we need to think a little bit about this here. Again, using my right-hand rule here. Well, remember, if I'm my positive z is pointing towards me. My quad that I was actually drawing, and let's actually run our program here. well, it's sort of been pushed out into the scene, right? Some negative direction. In fact, let's go ahead and see that just as a recap here. Let's open up our source code in source main, and I'm going to look for our model matrix here. Okay, let's see if we actually pushed. Did we translate our object? Well, we set it to some G underscore offset here. Okay, now let's go ahead and see if that is true. Yeah, we pushed it -2 units. So again, do your right hand rule, and -2 is sort of pushing out in the screen. Positive would be behind us, okay? So our camera, we want to be looking sort of in the negative direction, okay, if that makes sense here. It's a little bit unintuitive sometimes, but that's, you know, sort of the idea here. And, you know, usually it doesn't really matter if it's like -100 or 1000. I would just choose -1. It's a nice normalized value. And again, that ensures that we're just looking, you know, out towards our object here. Okay. Assume we are looking out into the world. Okay. Note this is along -z. Okay, because otherwise we'd be looking behind us. Okay, that's the idea. And otherwise, we'll assume we are placed at the origin. Okay, and again, if you're modeling this for a game or something, right, your actual eye position might be like a little bit elevated, right, because your character has height or something. But again, for practical purposes here, we could just assume that we're at the origin. Okay, so we've got our camera here, and then if I call this lookAt function, I should be able to actually get a view matrix back here. Okay, so let's start playing around with this just a little bit here, and we're going to need to go back to our source file and our main. Let's go ahead and include our camera. So let's go ahead and say our libraries now, and let's include camera HPP, and I'm just going to create a global camera. Okay, I know we don't like the globals. We can fix this or wrap them in a struct or something. But for now, this is fine. And let's create a single global camera. And you could have multiple cameras. That's how you could get multiple views, for instance, or if you've thought about split screen and gaming and so on, there's some different tricks that you can use for this, but just one camera for us will be fine here. Alrighty, so now let's actually do something with the camera here. And where I'm going to go ahead and start playing around with this is in the pre-draw function. Okay, because this is where we're handling all of our uniform variables here. Okay, so we've got our model matrix and we've got our perspective matrix. Well, the perspective sounds like it should actually be something that's part of our camera. Okay, so maybe in a later video, I'll adjust that. Okay, I'll make things a little bit cleaner. But for now, all I want to do here is just create a mat4 here. I'm just going to call it view. And I'm just going to, from our camera, gcamera, call get view matrix. Okay, which should return us our view matrix that's looking out across the scene here. Now let's do a little bit of copy and paste here for our uniform variables. And again, you know, at some point, you know, when you copy and paste something like 3 times or more, then it's probably time to start thinking of abstraction. So we might want to start thinking about this. But again, it's good practice, at least while we're starting here, to just go ahead and write these out here. Let's just go ahead and call this view and make sure that we found our actual location. And again, this is a 4x4 matrix here. So the view location, and make sure it is view here, which is a 4x4 matrix here. Okay, let's make sure that we provide the appropriate error message. Could not find view. And again, this is going to be a uniform that I pass in, because again, our camera is going to be something that updates over time and is changing, right? We might move the eye position. In fact, that's where we're heading in this particular lesson here. Okay. Alrighty, so let's go ahead and compile this, see if I made any silly mistakes. No silly mistakes here. Now, if I run it, it shouldn't work because I haven't updated my Vertex shader here, which is supposed to translate vertices based off of this view matrix, right? We're going to multiply this in here. Okay, so yeah, could not find the view here. So let's go into our shaders, our Vertex shader. We need to create this as the view. let's name it view matrix. I like it. That's just a little bit cleaner. Let's see here. So view matrix here. And let's update our error message as well. Here, uView matrix. Okay, so let's give that another compile. Okay, so it compiles. And then let's actually use it here. Now, again, a little bit of a trick question or, pop question here for you. Let's see here. Here, let's get rid of this window. Think about this, but where do you multiply in the view matrix here? Okay, now remember, here's our point. We go right to left. Here's our model matrix. Here's our projection. And then again, on our pipeline, I said that we're going from our local space. We multiply in model. Then we're in world space. And we multiply in view. And that takes us into this camera space. And then let's draw another arrow here. Roughly speaking, I'm going to draw it as like a squiggly. We eventually multiply in our projection. Because there are a few other spaces like screen space and so on after this. And that squishes effectively this scene or our triangle into, something that has perspective and depth here. Okay. With that in mind, if you guessed that we multiply in here, right, then you are correct. Okay, so let's put in our view matrix. And this makes up something that's known as the MVP matrix, which we've talked about a little bit in some previous videos. But again, you just got to remember to multiply your actual point here. And it is a point, that's why W is 1.0 there, but by M, V, and P here. Okay. So let's go ahead and compile that. It compiles. Our shader has found it. We're still looking sort of down towards our object, and we're still able to offset our object here. Now let's see. If I'm holding up, I'm still moving towards it, and left and right is rotating. Okay, now let's actually add something in for our camera here, right? Rather than moving the actual object here. And how are we going to do this? Okay, let's think about this just a little bit here. Let's open up our main source file here. And what I'm actually going to do here, let's get our object rotating. Let's see where we have rotate here. I think what I'm actually going to want to do for rotating is get rid of this here. And let's actually just have our object always rotating here. Okay. So let's get rid of this here. Actually, let's keep this here for now. And for our object offset, let's hold on to this, but we basically want to make sure that our arrow keys are just moving our camera, okay? So let me clean this up just a little bit here. Actually, let's get rid of the offset. We don't really, well, maybe let's just hold on to it here. We might need it for something else here. Oops. Let's get rid of it here. And I'm just going to put a little to do here. To do, use some other key to move our object. Okay, we might want to do something more interesting later on with it moving it about. But what I actually want to do here, though, is move our rotate. And probably the right place to do it is in pre-draw. Okay, so, before we draw things, let's modify our object here. Let's go ahead and just put it here. And let's see, I'm doing it by -1. I don't really care. I just want to do it by a small enough value so that our object's moving around here. Okay, so let's go ahead and compile, make sure I didn't break anything here. Let's see, here's our object here. So it is rotating. Now, interestingly here, though, it's leaving our screen here. Why? Well, again, remember that the order of transformations matters. So if I rotate my object first and then translate it, well, then we're effectively rotating and then pushing our object out in some direction. And that's how we create an orbit. This is actually important here. So let's change our order of operations here just a little bit here. Where I'm going to instead, Let's go ahead and do this here. Do our translation first, which we're not really translating anywhere. I think our default value was to push it back -2. So push it back -2 and then rotate it. Okay, so we should see a rotating quad on our screen here. If I rerun this, and let's see if that's true. Oh, I'm getting an empty screen here. So let's debug. So you should get an empty screen too. Let's see, what can we do here? Maybe our, let's see, what is G? Let's see what our offset is here. Okay. Oops, we got to go to -2, so push it out into our scene and then rotate. Okay, let's see, where did we leave off here? Let's check it out here. Oops, no highlight. Okay. And this is going to be a classic copy and paste error here. I need to start off with a matrix that's at the identity. I bet this is the issue here. Mat4 and specify 1.0 and then rotate around my model matrix, which is the thing that's been updated there. Okay, let's see if that does the trick here. Well, let's see how my graphics knowledge is. Okay, still working, still following along here. Okay, so I've got a rotating quad here. Okay, so something similar enough that we've seen here. And we can smooth it out or you can play around with it here. But now what I want to be able to do is update my eye position here. Okay, so let's go ahead and look at our input here. Right, and this time what we're actually going to be doing is when I press the up key, let's do our G camera, should be, what did we call this? Move forward, something like that, move forward. And let's go ahead and go into our camera. Let's go ahead and split the window here. And we've got move forward and so on. Now it might also be nice to specify a speed for these. And again, this is for my folks who are coming from Unity or Unreal or some game engine where you want to multiply in a delta time or something. Have a little bit of a control over this. And if somebody doesn't specify, we could pass in a default parameter here or something. I'm going to say that we have to do it. So we also need to now update our header file. So just a few quick changes here, and then we'll actually get to adjusting things. And then we'll move to another video to handle things properly, but let's just see if we can get some feedback here. Okay, that looks good to me. All right, now here's the question here, and let's update this. Put in a new line there. There we go. And what I want to do here is, okay, if I hit the back key, then let's move backward. And appropriately, if I hit the left key, let's go ahead and G camera move left. And I know for my gamers out there, me included, WASD is fine. You could also be using that. That's fine. I might change it later, just because it's a little bit more natural. But I think this is very clear what we're intending to actually happen here. So, okay, if I want to move forward, what's the cheapest, simplest way you can think about just moving forward? Let's not even worry about, what happens when you turn left or right. I want to solve that in another video because I think it's interesting. But let's just do something simple, but not yet correct, okay? Need to fix in next video. So we'll have to stay tuned, or maybe as an exercise for you, if you want to fix it at this point, I think that could be useful. But let's just adjust our eye position, okay? And where is forward, if I think about this in terms of X, Y, and Z axes, well, that's probably something to do with our Z position here, okay? And what does forward mean? Probably means we're moving in the negative direction from which we are currently looking here. Okay, and we just want to adjust that by the speed here, okay? And then backwards must be, well, minus equal speed here, okay? And we have to determine what speed is here. For these, I'm just going to go ahead and create some float speed here. I don't know if that's a good value or bad value yet. Let's just go ahead and run it. And again, you'd want to do this by delta time. Maybe we'll add that in here. I talked about that a little bit in my SDL series. but let's go ahead and give this a try here. So our application is running. Now let's see if I press forward. Well, I'm moving backwards and backwards. Okay, so I reverse those. Yeah, forward, I want to be moving along the negative axis. So let's go ahead and fix that. But we do have a working camera in some sense here, okay? Plus equals speed and minus equal. Yeah, and let's update our move speed, something like -0.1 here, okay? So that's pretty cool here. Let's go ahead and just do it. If I tap, I'm moving forward and back. Of course, if I move through the object, then it's gone. But I can move back until we hit our far plane, which effectively is clipping or getting rid of our object, right? If we move too far away. Okay, so there we have it. That's a simple camera here. I think I'll go ahead and leave it at this point here because I'm quite happy with this camera that we have. But as I alluded to, and you're going to have to check this in the next video here, it's not yet correct, right? Just be moving us forward and backward by adjusting the eye position. Now, again, it depends on what types of graphics applications you're doing. Maybe if it's a 2D game, for instance, it's enough to sort of have some sort of like zoom in or zoom out, and that's effectively what we're doing. But what if I want to sort of turn and move based off of like a first person perspective. So those are some questions that we'll have to answer a little bit in the next video here, but I think this is a great point for us to go ahead and stop otherwise here. All right, folks, so with that said, I hope you enjoyed this lesson. Hope you're having fun in the OpenGL series. I know we had a while between some videos here, but this is cool stuff. Again, having a camera that we can move around in and change the perspectives here, I just think it gives a whole new feel to our graphics applications. Now, again, the little bit of a mind bender when it comes to the camera is it's effectively doing, something similar to what we were doing when we are moving and translating the object, but now we're just viewing it from a particular perspective. Or I shouldn't say, well, it's a combination of a perspective and that special lookAt matrix, which gives us the view matrix or the camera matrix, which we multiply in, which when we multiply a matrix by a vertice, right, it's taking all those vertices, multiplying them and adjusting their positions based off of where we are. So the camera, again, driving that lookAt matrix is kind of interesting because it's kind of, however you want to think about it, as pushing away all the objects or bringing them towards the camera, depending on how you're moving, is interesting to think about. But anyways, folks, with that said, thank you for your time and attention. Hope you're enjoying this series. Let me know in the comments below or in the discussions what your thoughts are, or if you've already figured out how to create the first person perspective and the camera without actually looking ahead. If there's already been videos released, then let us know what cool stuff you've done. Anyways, folks, with that said, I'll look forward to seeing you in the next one.